Okay, so since this is a cumulative exam, and it's really like an 8-week cumulative exam, it's covering experimental design material from the first week, or from the very first. So they're not majorly intense experimental design questions. They're enough that we can review it right now, and hopefully you knew it well enough it'll quickly jar your memory. So I want to, so that we have enough time, actually start in the last problems. I'm going to work from the back of the review forward. So if you will go to the very last page, which I think is page 68. Okay, so on the test, there are 2 multiple choice questions, just like there are 2 multiple choice questions on this review. And they're very similar to the review ones. They're the like kinds of problems. So what that means is that there is a SRAP-ME cap and a BRAP-ME cap as one of the free responses on the test. Okay? So we got to review that. So let's take a look at this last page, page 68. I think it said to draw a diagram, but that was before we learned how to write paragraphs, so I would prefer what we have been doing this year with the paragraphs, SRAP-ME cap and BRAP-ME cap. So let's review. I'll kind of sing the song to you. So what's the S is when we start with the subjects that you have. So we start with 80 patients. And what's the R in SRAP-ME cap? R. Randomly assign them with a big bag. Okay? And then the asterisk is the big bag part. Okay? All right, so start with 80 patients and put them in a big bag. Shake well and randomly assign 20 patients to each of the, what is the T in the song? Treatments. State your treatments very well. So there are 4 skin cream treatment groups.
Did you say one of the 4, like assigning one of the 4 cream stage group? Like, do you have to say treatment group?
You are assigning the patients to the creams. Yeah. Okay. Yeah. So assign to the treatment. So instead of saying put the yeah.
Well, I said assign the 20 people to one of the creams.
Yes. Okay. And then ME is measure each subject's skin disease improvement. Be careful to look up there and see what it was that they wanted. What were they looking for? Were they very clear? It just says, yeah, the effectiveness. Study the effectiveness of the 4 different skin creams. Okay? So that's how you would want to describe that. So I guess I described it as improvement. Okay, now I described it on a scale of 1 to 10. Some people might have decided if it improved, yes or no. Okay? And then compare your average or your compare your average or your proportion. So compare the average effectiveness of all 4 skin creams to see. Next year I'm going to fix the song and add the T for to see which skin cream is the most effective. Okay, so do you see how I'm using the exact same language that they used? They said we were comparing the effectiveness of the skin cream. So I'm using the same language that they use. Okay, questions there? SRAP-ME capped. SRAP-ME capped. Shake your bag up. Shake your bag up. All right. And you're welcome. You can take a picture of that if you want to. Okay, I can put that back up later. All right. So now, look what happens in the second part. It has been determined that the skin type, which is fair, medium, or dark, could affect the rate at which the skin condition clears up. So do you remember what we do when we have a situation like that? Yeah, so do you remember the song, I see you have a trait there that may affect the way subjects respond. See, I see you have a trait there, that you have fair, medium, or dark skin. And I see you have a trait there that may affect the way subjects respond. So what do you do? What do you do? Make homogeneous groups. What do you do? Make homogeneous groups. So, here's our Babratmi capped. So, the B at the beginning is block by skin type, fair, medium, and dark, because block by skin type because skin type may affect the rate at which the skin condition clears. You have to have this part here because the skin type may affect the rate at which the skin condition clears. That's why it's Babratmi capped and not just Bratmi capped. It's BB for blocking because. All right. Now, from there, it will be most clearly done if you Ratmi capped in one of the blocks. Ratmi capped in one of the blocks, and then after you do that, say repeat in the other blocks. So I'm going to finish out the full Ratmi capping in the fair-skinned block. So see, in the fair-skinned block, put all the fair-skinned patients in a bag, shake well, pull them out, randomly assign. How many am I going to randomly assign? Do you know how many are fair-skinned? No, you do not. So you're going to say 1/4 of the fair-skinned patients to each of the skin cream treatments. All right, then measure each subject's skin disease. Compare the average improvement of the 4 skin treatments. This isn't still in the, this is all of this section right here, guys, all of this component right here, all of that statement right there, the Ratmi capped was all about the fair skin block. So I completed the experiment in the fair skin block, and then I finished it off by saying, repeat the above experiment in the medium and dark skin blocks. I found that if my students tried to do it all together at once, and they said, within each block, do this, blah, 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 I found that when they got down to the comparing, they were really unclear what you were supposed to compare. Are you supposed to compare, you know, treatments A, B, C, and D in the fair to themselves, or A in the fair to A in the medium to A in the dark? Anyway, my experience is if you don't do it this way, the comparison becomes unclear and I mark it wrong. Okay, there's a big review there. Okay, moving on. Okay, anybody want to take a picture of that? Yeah, take that picture if you need to real quick, if you didn't get it written down. Okay, now let's go to the other kind of problem you're going to have. That's one of these ones. This was an actual AP question on an actual AP exam, where, do you see, they gave you all this data and they asked you to graph it. So look at there, they even put the scale on it for you. So if your box plots do not look exactly like mine, then you did them wrong. So you can tell on the AP exam, everybody's would have looked exactly the same. I did the Q1 and the median and the Q3. Do you see how my whisker does not go to the fence? This upper whisker just goes right there to that number 7. Was there an upper outlier on that one? Yeah, 9. 9 is an upper outlier, and an outlier is a dot. Now, one person in my third period determined or told me that that -10 was actually a super special outlier. That was one of those ones that went past 3 IQRs. I don't think they marked it off on the AP. If you didn't have an asterisk there, they just wanted to see that you had it as 2 separate outliers.
If the 8 is right on the super one, do you...
I don't know. I just called it regular, I guess, but I don't know. But they didn't mark wrong on the AP if you made it an asterisk or not. Okay? All right. And then here is what the other one looked like. It did not have any things. Okay, So finally, this is about having an additive and not having an additive and seeing if you got better gas mileage. Okay, so after looking at these two, so positive numbers means the additive got you farther distances. So based on that, which one of these do you think is a better additive? Additive A or additive B? What do you think, Carson?
For achieving like what it asked for in C?
It just says, yeah, in that part it says, which additive, A or B, would you recommend if the goal is to increase gas mileage in the highest proportion of cars?
Well, A because it's like more percent, because it's more than 75% of the 0, which marks it.
Okay.
That's what I said. But I
Okay,
said
cool.
B, you have a more drastic increase.
Okay, cool. So they actually accepted either answer, A or B, but you had to support it. So you could say exactly what Carson said. He said additive A because he explained that you have over 75% of your data had positive amounts. Okay, but maybe who picked B? Who thinks B was better? Okay, and what was your reason why you thought B was better?
I said that 50% of the data set with additive B had a higher gas mileage than 75% of A.
Yep. See this right here? Well, I don't know about that. 50%, this 50% has better gas mileage than the bottom, less than 25% or something. Well, but look here. See this top 25%? That one's above the whole thing. I mean, so you just had more data that was much, much higher than the other one. Okay, so they could support either one. Just pick one and support it. All right.
Is that gonna be like
Questions there?
like well you won't
Will I do something like that? Maybe.
like accept either one?
Could be. I mean, maybe.
There might be a right answer.
Okay. Continuing to go backwards. Here we go. I want to go backwards because the experimental design ones I want to do earlier in our class before you start getting brain dead. So here we go, number 24. Which of the following are important in the design of an experiment? So let me ask you this. You make an experiment. What do you do? Control, randomize, repeat. You make an experiment. What do you do?
Control, randomize.
Good. So look at this. While the book says B is the answer, which is 2 only, I say, why the heck is A not part of, why the heck is number 1 not included? Because you make an experiment. What'd you do? Hello, we control and we randomize. The only thing I can think of is they're being all picky and saying you don't control confounding variables, you just don't have them. So, I don't know. But anyway, so I would have picked E. Next. So another thing I want to talk to you about as a reminder from this unit was experiments. You can, in an experiment that is randomly assigned to the treatment group, you can claim a cause and effect. Okay, so the only way you can claim a cause and effect is if you randomly assign to the treatment group. Get them for me. Hello. Can we have class? That would be super swell. Okay, I don't mean to interrupt y'all's discussion. Okay, thanks. Sorry, I didn't want to be rude. Okay, so if we got an experiment, in order to claim cause and effect, you need to randomly assign to the treatment groups so that you can do it. Okay, well look here what happened on this one. We had 3 treatment groups. The nursing home that had an hour a day of pets, the nursing home that had an hour a day of kindergartners, and the nursing home that has antidepressants. And so all of the ones B through E are true. You can't do cause and effect because they did not randomly assign the elderly people to the treatment groups. Okay, those weren't a random selection. It couldn't have been a particular quality in one of those nursing homes that makes one of them do better. Anyway, there was not a control group. What would a control group have been? One with nothing. Okay. None of these studies used blinding. That is also true. And it says important information can be obtained from all these studies, but none can establish cause and effect. Because in order to do cause and effect, you randomly assign to the treatment group so you can claim the cause and effect. Okay, so they didn't do that, so we can't claim cause and effect. All right, number 22. Hey, what's the purpose of blocking? Reducing variation, you remember? Blocking reduces variation. Okay, we know we got our blocking song, which I already sang part of it to you. So blocking reduces variation. Because what kind of groups are you making when you block? Homogeneous groups. Okay, so you've reduced the variability in those homogeneous groups. All right, next, number 21. I do not like this problem at all, so I would have omitted it. In fact, this used to be a test. I hope I omitted that one on the test because, I mean, I think, one, I don't get that that's a definite thing, and then 2, I'm not sure about either, but 3 is true for sure. 3 is definitely doing that stratifying by counties. Stratifying is not a simple random sample. Okay, so stratifying is definitely not a simple random sample, which takes us up to this one, number 20. This one is C, and here's why. Let's review how they're doing this little information. There are 7 teams in this basketball league. Each team has 12 players. So there is a total of 84 players in the league. 84 players in the league. Okay? So it looks like they're wanting to get a representative sample. So they're wanting to pick 2 players from each team. So if they pick 2 from each team, what kind of sampling is that? 2 from each. That's stratifying. Good. Stratify, homogeneous, because they're picking some from that one and some from that one and some from that one and some from that one. On our video, what picture do we have to represent that stratifying? Remember the Skittles? Remember the bowls of Skittles? Those were all the same color. That was stratified. Okay. And then we got some of you and some of you and some of all of you. Well, here is the definition of a simple random sample. Okay, so look here. A simple random sample, one of the qualities of a simple random sample, let me go ahead and define that for you, is that every combination of, and in this case, size 14, because that's the sample size that they are picking, every combination of size 14 is equally likely to happen. Is that possible when they pick 2 from that team and 2 from that team and 2 from that team and 2 from that team? Is every possible combination possible? Would a combination include 12 from one team and 2 from another team? Yeah, that should, in a simple random sample, the simple random sample is the big bag. And the simple random sample is the big bag, and you could pull out all of one team, 12 from one team and 2 from another. That could happen with a simple random sample, but not with this stratified situation. So this is not each group of 14 has the same chance of being selected. Therefore, it's not a simple random sample. Okay, moving on. 19, I don't really like this problem, so we're going to skip it. It is supposed to be, remember that if you have voluntary response, you call in, you are very driven by that question, you're affected by it, so you take action and you place yourself into the sample. So E, it's not a good one, but the answer is E. All right, number 18. If you have a careful use of control groups, experiments can do cause and effect. True, because you can randomly assign to the treatment groups and you can claim a cause and effect. How about observational studies? What do you do with an observational study?
You observe.
You just observe already existing conditions. So are you ever able to claim cause and effect from observational? No. No, no, no. So statement 2, observational study may suggest cause and effect. That is false. Okay, statement 3, though. I actually disagree with I disagree with this one. Because let's talk about it. So I don't like this answer anymore. I like one only. And that's not an option, so I'm going to say none of the above. Did anybody else pick that? I think that's proper. I think that's correct, because let's talk about what Statement 3 says. Statement 3 says, a complete census is the only way to establish cause and effect. Okay, what do you get from a census? What happens in a census? You ask everybody information. In a sentence, you ask everybody information. So you are just doing what? Collecting data from everybody. And that is not assigning everybody to a treatment group. So no cause and effect, because you're not assigning everybody to a treatment group. You're just collecting already existing data from them. All right, next. Previous page, number 17. It's D, because the first one doesn't have a control group and the second is an observational study. And then 16 is a good one here. It is D. In an experiment, a treatment is intentionally, now do not get hung up on this word forced. It's intentionally imposed upon one of the groups to see if you can have a response. In an observational study, the information is gathered on already existing. How about a sample survey? What are you doing with a sample survey? If you take a survey of people, what are you getting? Information. What are you asking them? About stuff that is already happening, is already existing. So taking a survey is collecting data on a already existing situation. So that is an observational study. So 1, 2, and 3 are true. Yes.
Number 2, would like a prospective study be gathered on our existing situation?
Situation, yes, because like you could even take like identifying the kindergartners. They're already existing, and then you're going to follow them. Yeah, not already existing data, already existing situation. Okay. All right. Moving up to these 3 right here. Number 13 was C, number 14 was C, and number 15 was A. That was just some basic straightforward. Can you take those probabilities? Questions? Okay. We good? Okay, moving forward. Number 12. What is the definition of variance? Very good. Variance is standard deviation squared. So that's why it is 29.16. Number 11 is also a problem where you are straight up seeing if you can compute the fences. Your IQR is 4. So here is Q3 plus 1.5 IQRs puts your fence at 13. So 14 is an upper outlier. Q1 minus 1.5 IQRs puts your lower fence at -3. So there is no lower outliers. So 14 only is the outlier. Okay, now let's talk about this one. So see this number 11. This is a bin from 110 up to 120, but not including it. This next is a bin from 120 up to 130. And this is a bin from 130 up to 140, and so on. Okay? And then those are those bins. So it's like a histogram. A stem and leaf plot is like a histogram, not a dot plot. Did anybody think dot plot? With a dot plot, you have individual data pieces like this. Okay, remember that I had come back and I had fixed that and corrected that. You can tell the individual information from a dot plot because they are on each individual number as opposed to a bin of information. This is a collection of data.
Because it's all within like the same 10.
Yes. Okay, so that's why it's not a dot plot. Okay, and then hence number 10 is D. All right. Moving forward. Number 8. Okay, so the dispute on this number 8 seems to be majority. What is a majority? How much is a majority? More than 50%. So is it true that more than 50% of dogs get to ride in the front passenger seat? Yes. Majority means more than 50%. So B is true statement. But what can you tell me about all these numbers, because they total up to more than 100%? What can you say?
It's not represented.
Mm.
People are double counting.
It cannot be a pie chart, but what can you tell me about the dogs in this thing? They overlap. The owners have, some of the owners have their animals located in more than one, let them sit in more than one place in the car. So there's overlap. You cannot have a pie chart if you've got overlap. All right, number 7 is D, and number 6 was B. Questions there? Okay, moving forward, number 3 is C, not B. Look, I've gone back and forth over the years between B and C, but I feel confident now that it is C, and here's why. What percentile is Q1?
First 25.
25th percentile. So look at these two bins. These bins contain how much data? 24%. So therefore, Q1 is going to fall in that next bin. Okay, do you see that? Q1 will fall in that next bin because those first two bins contain 24% of the data.
Yeah.
All right, now, next one. This one is A, and here is why. If you totaled this thing up, there's about 66 pieces of data. Okay, remember I told you that you need to be able to do this yesterday when I went over the warm-up with you? If there's about 66 pieces of data, the median is located about the 33rd to 34th piece of data, and that is right here. So the median is between 0 and 1, and Q1 is located at the spot data item number 17. So Q1 is right there. So Q1 and the median are in the bar 0 to 1. And this is the only one that has the median and Q1 in this bar from 0 to 1. Okay, questions there? All right, moving on. This page, I kind of also disagree with something on this one, but let's talk about the answer is definitely C. I don't disagree with that answer. I disagree with their number 4.5, and let's talk about that. If you have skew, then what measure of center should you use?
Median.
We should be using median. And so if there are 140 songs, what piece of data, where is the piece of data that's the median located? Between the 70th and the 71st piece of data is the median. Well, here is about 23 pieces of data. Here's about the next 56 pieces of data. So the median is located somewhere right here. So where is the median located? In what bar? This bar here, and this bar is from 3 to 4. So I'm disagreeing with this 4.5. So why do you think they got 4.5? I have a theory. What measure of center do you think they used? If they used mean, because guess what? The mean is greater than the median. So perhaps they represented with the mean, not the median, but that's really not proper. I mean, it's not against the law or anything, so some people might do that, but it is better to use the median. Okay, moving on. Number 1 is D, but then let's talk about number 2. I don't think there's really this problem situation on the test where you're going to really need to know how to do the formula for standard deviation. But let me go ahead and show you, remind you of that. So here we go. So the formula for standard deviation So the standard deviation is the square root of 1 over n minus 1 summation of the individual minus the mean quantity squared. So look at what they say. They say calculate the differences. That's all of these right here. Find every single one's differences from the mean. Square those differences. That's this piece right here. The sum of it, that's this sigma. So they found this section right here that I'm highlighting to be what value? Okay, the sum of all those squared differences is the value 218. Okay, so that's what the sentences say. The square of that red section, or the square of those differences summed up, is 218. So now how do we finish this out? Divide by n minus 1, or multiply by 1 over n minus 1. So you take 218 and divide by 9. And then that's the variance, so the final step is to then square root that. So the square root of 24.22 is 4.92.